In this video, we will talk about the surface of revolution. So as you can see here is the basic equation for surface area, and it looks pretty similar to the arc length, but with just the 2 pi and the fx in the integral. So let's take a look at the differences between the surface area, the x-axis, and the y-axis. So here we got the x-axis and the y-axis of the surface area, and as you can see here, this is very different because here in the x-axis you have a fx, and the derivative of fx is squared here, but here you have fy. This is in terms of y, and the derivative of fy squared right here. So when you're given a question or something, they will probably ask you to find it in terms of y, in terms of x, and this is basically what is much needed for that. And now let's look at some examples. All right, so here we got an example, and I'm gonna keep it straight simple. So basically we're finding the surface area with respect to x, and here we're given a function of y is equal to cube root of x from 1 to 8. So let's keep it simple. So let's start off with respect to x, and first we're gonna have to rewrite this in the fx term. So let's make it much more easier. So the y fx is going to be equal to third root of x. Now let's rewrite this. So third root is going to be pretty much similar to 1 over 3. So 1 over 3 will be the exponent. Now let's derive this. So we can bring this down, do simple derivatives. So we can bring 1, 3 down, x. So 1, 3 will minus 1. So this would be negative 2 over 3. It will be 1/3 x still. And it will be x squared to the cube root. So that. Now we're going to square our derivative. So let's see here. We're going to square this. So we're going to square this. So we will square this. And this would be 4 over 3. And this question, we're just setting it up. We're not going to do any hard stuff. This is just simple. And put this in for reference. So this will be the equation that we will use. So this will be much more easier to do. If we have our squared derivative, we can just plug and chug. So it goes from 1 to 8, and we got 2 pi. Fx was cubed root of x, and we got 1 plus. This would be 4 over 3. We set up equation for surface area. After when you do that, you're going to have to integrate, but this is just simple explanation just to get the basics. So this would be the answer for with respect to x. Now we're going to look at with respect to y. So we're going to rewrite this. So this would be x to the power 1 over 3. And we're going to find this in terms of y, so we can cube it. So we can do this. Because this will be go here, and then this will cancel out. So x will be equal to y cubed. And now we are going to take the derivative of this. So bring the 3 down. Should be like that. Let me just make this better. So we can just plug in 1 for x. So let me just put it right here. We're going to plug in 1. So cubed of 1. Cubed of 1 is going to be 1. And cubed of 8, that is going to be 2. So our new y values would be 1 and 2. And we got our square derivative over here. Now it's time to plug it in. So surface area would be from 1 to 2 to pi. In this case, we are going to put y because it's going to be like that. And plug in our new square derivative dy. This is how you set up in terms of y. So we're doing this question in terms of x-axis, and the reason why we put y over here is because when we find this answer about the x-axis, when you're given a question, it says with respect to y, you're always going to put y here. And when it says you're doing it or finding an answer in terms of about the y-axis, you're going to put x, and the y would be the equation. I'll show you that in another example. So here we got another example. It's kind of similar, but it's about the y-axis, and the function is kind of different. So we're going to start off with the y-axis, or we're going to find it in terms of x. So xy equals 4. We can divide x to only find y. So y would be equal to 4 divided by x. We can derive this. We can rewrite this in terms of negative, so it'll make it much more easier, and we can derive this. So we will bring down the -1, and it will be x minus 1 minus 1, that will be -2, and this will be -4 over squared. Squared is 16. X squared is going to be x to the power of 4. And we're finding this in terms of, well, rotated about the y-axis. So our final answer would be the number of values to pi and put in x instead of, the function, and just plug it in at this point, dx. And this is only just a setup. This is only just a setup, not like the actual thing. So, but now I will show you guys the actual. Remember, this is rotated about the y-axis, but we're finding it in terms of respect to x. So this was our original, and we can divide by y. So this would be 4 over y. And when we can derive this will be, the same thing as before. So -4 over x squared. Now we can square this. and that will be same as before, 16, but with a y to the power of 4, my bad. I accidentally put x, and this will be 16 over y to the power of 4. Now we have to plug in we have to find in our x values. So our y values were 1. We're going to distribute this or plug it in. So this will be our x value is now 4, and we plug in 8 for y. This would be 1 over 2. Now we're going to plug it in just to see how it looks like. So this would be 1/2 to 4, and plug in 2 pi. And now we're going to put in our this value because it is rotated about the y-axis. So this would be 4 over y, and we can just plug in our derivative squareds. And as you can see here, when it says dy, like everything has to be in terms of y, and it's in dx, everything has to be in terms of x. So yeah. Oh yeah, guys, just for some clarification, when it says about the y-axis and they give you a function, whether it's in terms of x or y, the function that will have like the actual, like another function outside of the square root would be like that would show like y. But if it doesn't say like, oh, let's say like it doesn't say about the x-axis, right? So you would just plug in for in this slot, you would just plug in x, and yeah, as you can see here, like you can see the actual function here, and but you don't see it here. You just put in x because it's asking it about the y-axis, not the x-axis. And this is vice versa. If it is rotating about the x-axis, you would plug in the x function value into the equation, and you would just plug in y as a substitute. Like in here, you just plug in y if it was asking about the x-axis. So I just want to make that clear. We're trying to find the surface area by rotating the curve about the x-axis. And for starters, we can just find our derivative as always. So let's bring down the 3, and this would be 3x squared. Now we can square the derivative. So 3x squared would be 9x to the power 4. And now our second step is to just plug it in to the equation. So since it's asking about in terms of about the x-axis, so we can just plug in 0 to 2 here, plug in 2 pi, and we can plug in our actual function because this is rotating about the x-axis, so we don't have to put in x or y. Just put in the function for this example, and slide inside the square root would be 1 plus 1 x to the power 4 dx, and now we're going to integrate this. So we're going to try to integrate this. So this seems like a lot, but we can use u substitution here. So this would be 1 plus u would be 1 plus 9x to the power 4, and the derivative of that would be 36x to the power of 3. We don't have that in this equation, so we have to divide that by 36. And we are left at x to the power of 3. And what do you know? We have x to the power of 3 over here, so we can just like substitute it for that. But we still gotta plug in our n limits. So we have 0 and 2, so we can plug in 0 for x. 0 to the power of 4 is 0 times 9 is 0, so this would be just 1. And plug in 2, 2 to the power of 4 is 16. And multiply by 9, that would be 144. And plus 1, that'll be 145. So we're done with this section. Now we gotta just do it. So now we got this. And leave the x to the power of 3 for alone right now, and we can just put in our u. And we can take 2 pi out of the integral. So this would be u 1/2, u to the power of 1/2. So let's integrate it so we can do this. 1/2 plus 1, that would be 3 over 2. We can divide that by 3 over 2. Multiply the reciprocal, that would be 2 over 3 u to the power of 3 over 2. And now we have to plug in our new values. So this would be step C. And now we got 2 pi. We have 1 over 36 du over 36. So we can just put 2 pi times 1 over 36. The du will be canceled out to nothing, so don't worry about that. And we have the 2 over 3. So all of this will be multiplied into u. So now we're gonna plug in our values. So we got 145. So 145 3 over 2 minus just 1 3 over 2. This would be equal to 1. And this would be equal to 145, square root of 145. Because if you plug it into the calculator, this is the exact same equation, the exact same value. So I know, guys, this is just bear with me. When you multiply 2 over 3 times 1 over 36, you get 1 over 54 times 2 pi. And 54 divided by 2, and 2 pi would be multiplied here. But we can simplify this further, and 2 pi would be reduced to pi over 27. So our final answer is pi over 27, 145, square root of 145 minus 1. Okay, so here we have another example, and this time you're giving it in terms of y, but this is still about the x-axis, so let me just make that clear. So our first step is to derive this. So we can bring down the 3 over 2. And this would be 2y because we are derivating this inside of this. So next we have to square this. So let me just make it simpler. So I will multiply all these. I would be end up with y squared plus 2 and I would square all these. So my new derivative squared would be y squared times y squared plus 2. So our values would be over 1 and 2 in terms of y. So this would be 1 and 2, 2 pi, 2 pi. And this would be y because we are still about the x-axis. We're rotating about the x-axis. So this would be y. And we can plug it in. So 1 plus y squared times y squared plus 2. We can actually distribute this. So this would be 1 plus y to the power 4 plus 2y. We can make use of this. So 1 plus y 4, 1 plus y to the power 4 plus 2y. We can distribute it further. So this would be y squared plus 1 because squared. Because distribute these, if you distribute it, it will be the exact same as this equation or this values. It will be the exact same as this. And yeah, this will make it much more easier. So we can leave the 2 pi out of the integral. And when we square this a square, we are left with just the value. So this would be just y squared plus 1. And this makes it much more easier to distribute. So now we got to distribute the y. So this would be y to the power 3 plus y. And now we can integrate this. So simple integration over here. From 1 to 2. Now we have to plug it in. So plug in 2 for y. Plug in 2 for y. And just like that. Plug in 1 for y. So we left with 16 over 4 plus 4 over 2 minus 1 over 4 plus 1 over 2. And we can minus this easily. So 16 over 4 minus 1 over 4, that would be 15 over 4. And 4 over 2 minus 1 half would be 3 over 2. We can make this simpler by having the same denominator. So times 2, 3, so 4. When we add this up, it will be 21 over 4. And we still have to times by 2 pi because we left it out of the integration. So this would be 2 pi times 2 pi times 21 over 4. And we can cancel out the 2. This would be 21 pi over 2. So this is our final answer.